I'm Petros, founder of Tesseract. Real-time AI needs sub 100 millisecond latency, but centralized clouds can't deliver that globally. Physics just won't allow it. And not all AI chips are equal. GPUs, Cerebras, Grok, etc. each has trade-offs. Tesseract solves this by routing inference across the optimal hardware closest to the user. Here's how Tesseract works in practice, routing real inference requests with latency and compliance guarantees. This map shows 30 simulated clusters worldwide, each running different hardware. When a user sends a request, Tesseract evaluates latency, region, compliance, and model compatibility to pick the very best execution site for that user. Onto latency analysis, this heat map tracks cross-region latency in real time. For instance, Tokyo to Oregon shows 108 milliseconds, so we might avoid routing across that path for time-sensitive requests. Onto our health dashboard, our router also tracks chip performance across a variety of different metrics. Some H100s here are overloaded with 78% utilization and 45 millisecond queue times. Meanwhile, this Grok LPU is only lightly loaded, so latency critical requests might go there, while simpler batch jobs might be sent to these GPUs for efficiency. Now, let's simulate a real request. Let's pretend that we're a healthcare company, and we need a Llama 3 70 billion parameter model. We have 70 milliseconds of required latency, and our user region is in the US East 1. And of course, since we're healthcare, we need HIPAA and US data residency compliance. Tesseract scores all backends and ends up routing to a Grok LPU in US East 1, the only backend to meet all criteria with the lowest possible score. And this score is based on an intelligent scoring algorithm from items listed here. Here you can also see which clusters were filtered out and why. Now, let's simulate a backend failure to show Tesseract's resilience. Even when our prime backend, which was originally the Grok, fails, it reroutes to a Cerebras CS2 in the same region, still meeting the 70 millisecond SLA with 47 milliseconds of expected latency. Notice the Grok backend now shows a failure error, fully tracked by our intelligence system. Now, watch 20 simultaneous requests, each with the same SLA. Tesseract distributes them intelligently, meets every single SLA, and takes 5 fallback routes without issue. And the average latency was still only 25 milliseconds. Tesseract is the routing layer for real-time AI, latency aware, compliance enforcing, and hardware optimized. We're now ready to deploy live clusters. Visit our website here and read our white paper to explore our full architecture and roadmap.